Hey there, universe nerds. Today we're chasing one of the biggest mysteries in cosmology. Something massive, invisible, and powerful enough to tug entire galaxies across millions of light years. It's called the Great Attractor, and it's been quietly pulling our Milky Way and thousands of other galaxies toward it at breathtaking speeds. But here's the twist. We can't even see it directly. It's hidden behind our own galaxy, cloaked in dust and stars, buried in what astronomers dramatically call the zone of avoidance. Let's start with the basics. When astronomers first mapped the motions of nearby galaxies in the 1970s and 80s, they noticed something strange. The galaxies weren't just drifting randomly with the expansion of the universe. Many of them, including our own, seemed to be moving toward a specific region of the sky in the constellation Centaurus. The speed, around 600 kilometers per second, or over 2 million kilometers per hour. That's not caused by expansion. That's a gravitational pull. Something out there was attracting us. At first, scientists thought the Great Attractor might be a single supermassive cluster of galaxies. But as telescopes improved, it became clear that it wasn't just one thing. It was part of a much larger structure. It lies in a dense region of the cosmic web, known as the Laniakea supercluster, which contains over 100,000 galaxies, including the Milky Way. In fact, you could think of Laniakea as our galactic continent, and the Great Attractor as the gravitational low point that defines its shape, the place everything around us flows toward. But here's the problem. The Great Attractor sits directly behind the center of our Milky Way, in a region packed with stars, dust, and gas that block our view. Optical telescopes can't see through it. For decades, it was literally a cosmic blind spot. We knew something was there, but not what. Astronomers had to rely on radio waves, X-rays, and infrared observations to peek through the veil. Slowly, a picture emerged. Instead of a single monster cluster, the Great Attractor seems to be part of a chain of massive galaxy clusters, including the Norma cluster, that together create an enormous gravitational basin. Even more mysterious is that the Great Attractor itself may not be the end of the story. Behind it, even farther away, lies another immense structure known as the Shapley supercluster, one of the largest concentrations of galaxies ever discovered. Many astronomers now think that the Shapley supercluster, not the Great Attractor, is the true source of much of the gravitational pull. In other words, we're not just being drawn toward one region. We're part of a much larger cosmic current, flowing through space toward the densest knots in the universe's web. To visualize this, imagine galaxies like boats floating in an invisible ocean of gravity. The Great Attractor is a massive whirlpool beneath the surface, pulling everything nearby toward it. But as you zoom out, you realize that whirlpool is just part of a larger tidal system, a network of gravitational flows shaped by clusters, superclusters, and the cosmic web itself. Our galaxy isn't stationary. It's caught in this grand river of motion, drifting towards something unimaginably massive we can barely comprehend. So, how do we measure this motion if we can't see the attractor directly? Astronomers use redshift surveys, mapping how galaxies move relative to the cosmic microwave background. That background acts as a universal reference frame, a kind of cosmic rest point. Against it, we can detect subtle differences in motion, small blue shifts or red shifts that reveal the gravitational tugs at play. It's from these measurements that scientists first realized our local group of galaxies, including the Milky Way and Andromeda, is moving toward the Great Attractor region. It's like watching invisible gravity currents ripple across the universe. And here's something truly humbling. While we're being pulled toward the Great Attractor, the entire structure itself is also moving, drawn even farther by other massive regions of the cosmos. It's a chain of motion that never ends. In the vast cosmic web, everything is flowing toward denser regions, while the empty voids expand. The Great Attractor is just one node in this gravitational network, one of many centers of gravity that shape the dance of galaxies. For a while, some people speculated that the Great Attractor might hide something exotic, maybe even a supermassive black hole or a region of dark matter far beyond normal clusters. But current data suggests it's made of perfectly ordinary matter, just a lot of it. Galaxies, gas, and dark matter combined into a gravitational basin so enormous it bends the flow of nearby galaxy clusters. The real mystery isn't what it's made of, it's how vast and interconnected our universe's hidden structure truly is. The more we learn about the Great Attractor, the more we realize it's not an isolated force, but part of the universe's large-scale architecture. It's a reminder that everything, even entire galaxies, moves together in a grand cosmic choreography. We may think the Milky Way is just spinning peacefully in the void, but in truth, it's racing across the universe, part of a river of galaxies flowing towards something far greater. So, what is the Great Attractor? It's the gravitational heart of our cosmic neighborhood, a mysterious region drawing galaxies across millions of light years. We can't see it directly, but we feel its pull every second, as our galaxy drifts through space like a leaf in a vast, invisible current. And just like explorers crossing an ocean, we're still charting where that current leads. One measurement, one map, one discovery at a time.